Can someone unmute Durga Prasad? He's from my team.
Yes, sir. Okay, sir.
Okay, is Dr. Rangasamy in the call? Dr. Rangasamy. Dr. Rangasamy in the call?
Rangaswamy. Okay, sir. All right. Yesterday I sent a link, sir.
I did send him to actually. He said he's going to join. So I'm just checking with him actually. So I'm actually trying to build him to teach.
Yeah.
Also because we are getting a lot of university colleges are asking us to teach. I'm actually preparing him to teach some of those classes.
Yes, sir.
So I was trying to see whether he's online or not.
So Rangaswamy sir is there, sir.
Okay. So then he may be muted. That's fine. So as long as he's there, that's fine.
I mute all the participants, sir. No more disturbances, I think, for you.
Okay, sir, no problem. And leave Durga Prasad unmute, sir, so that in case if I need to get in touch with him,
Yeah.
Durga Prasad sir is also a co-host, sir.
Co-host. Yeah.
Okay, okay, wonderful. Thank you so much. Sir, I'm ready. Whenever you're ready, we can get started.
Yes, sir. You can start, sir.
All right, wonderful. So I have two things to ask before we get started. I really want to thank you all. Typically what I have seen, day by day, interest goes down. People start with so much energy, enthusiasm, and when the days move along, they lose interest, and then things will get changed. But I see here a lot of interest, a lot of people are coming. It is really very encouraging. I want to thank you all for taking some time to come and sit down and learn this one. I really appreciate that your effort in learning this new concepts, new things, because you are the backbone, you are the pillars. You can learn and then go back and teach the students, correct? So they can also become an artificial intelligence subject matter resource and architect or whatever they want to do, correct? So I really appreciate that time you are taking to come and learn this one. So I have two things to talk before we get started today. So the number one, so what we have, so we really wanted to understand how much you learned so far, what we have taught you, okay? Even though it's a high level, but still we wanted to know, there's a lot of topic we discussed, a lot of things we discussed. So we have set up questions, something very basic, okay? Something very basics. It is basically not trying to measure you, how you are, where you are. This is for us to understand how much you understood, okay? So this is not, I'm going to send it to you because it is already marked with the answers. I'm sharing with you. So we are going to take the actual answers and send it to you. So this is one set of questions where it says simple, true or false. So this is to measure or understand how much you understood the concept. And there is a second set of question, okay? So this is again, true or false, fill in the blanks like this. There is mix of things. So you will also get this set of questions. And there is a third level of question. Each question has some advancements in terms of what we do. So I'm going to send this question to Dr. Deepl, and he will distribute to you. So I want you to complete this and send back to me, okay? So that I want to see how well this is received and what is missing in terms of the content delivery instruction, everything, okay? So I'm just going to send this to Dr. Deepl, and he will distribute to you. It won't take too much time. So before we meet tomorrow, I want you to work on this and send your answers to me. Okay.
Okay, sir.
It, like I said, it is very basic, correct? It is very, very basic. It starts with the very basic, then it goes little advancement, then it goes little advancement. So it's not too complicated, but you can refer something. You can also do this one. So please take this a little serious and try to get it done. All right. Thank you. That is my first topic. The second topic that what I wanted to find out from you. Do you feel that you are getting more comfortable, correct? Again, I said, correct, all the things what we talk needs in-depth, deeper discussion. Okay, every topic what we touched, it requires in-depth, deeper discussion. Obviously, in the short-term courses like this, we won't be able to spend too much time. But even though it's a high level, the one thing that you noticed, we really brought practical view on many things, correct? In the real world, how this works, correct? So that is how so far all the instruction and everything was structured and delivered. Okay. Obviously, there's a lot of technicality behind the scene which we won't be able to go too far. That's because we need such infrastructure, and those infrastructure we do have, but making it available live, it's going to cost money. So without the technical infrastructure, but we covered very much what you need to learn. So I'm asking from you, you can respond to the chat window so that I could understand. Okay, so what I'm asking you, the two days that what we spent on different topics, okay? So those topics, how do you feel, okay? Do you feel that you are gaining more knowledge? Do you feel this is something that, like, kind of little advanced? How do you feel about it so far, okay? So the reason I'm asking, I wanted to advance little more, but without knowing much, I can advance. So if you can respond, okay, maybe take 1 or 2 minutes, respond to the chat window. How do you feel so far? What I'm asking, are you gaining more knowledge? Are you feeling comfortable? Are you, like, able to get things that what you think you're going to teach, correct? So from that perspective, I wanted to know from you. Can you please respond to the chat window so that I could understand?
Participants are requested, please give your
Yes.
comments.
So very comfortable, getting more, better understanding. Okay. Okay. Anybody else? Okay. Anybody else?
Please.
Okay. Okay. All right. Thank you so much. Let's move on. Okay. All right. Thank you very much. So the only reason I'm asking this one, because I didn't go, typically these kind of sessions, there is more focus on academic side, less focus on industry. So I did not focus anything on the academic side, correct? I didn't go and talk about decision tree, random forest from, like, statistics or probability perspective, how it works. I didn't do any of those. I assumed you all know this one. Even if you don't know, I'm sure you can easily figure out, like, how a decision tree work, how a random forest work, and a regression works. So those are all, I'm sure you should be able to learn this by yourself. So I don't want to spend time on this one. So that's why I'm heavily focused on going on an industry side, trying to bring an industry view to this one. All right. So today, the same focus. So the morning session, I'm going to teach. The afternoon session, Durga Prasad is going to teach. So the focus for the morning session, understand the pending concepts, what we talked about. We talked about feature engineering, started with feature engineering, but we couldn't go too much. And then one of the use case that I'm currently working on, okay? Time series analysis, okay? Time series analysis. So we will spend time understanding what time series analysis and then demonstrate the actual implementation. In the afternoon, what Durga Prasad is going to do, okay, so he's going to focus on primarily on 2 use cases. And this was one of the requests that was made. So in the afternoon, Durga Prasad is going to focus on gender detection. I will explain what it is, and handwritten digit detection. So this was a request from Dr. Oblesh. So he asked us to cover this one. We are covering these 2. And the same example, the gender detection, handwritten digit detection, can also be implemented in deep learning that you will see tomorrow. Okay. In the tomorrow session, we will cover this one. Okay. So today our focus, I'm going to focus on the pending machine learning concepts and time series data analysis use case and end-to-end implementation. All right. With that said, let's move on. So where we stopped yesterday, so we actually started from here. I'll do a recap from here, then we'll understand. So we understood all the basics. So now we are trying to move on to how do we implement machine learning. We need a problem statement. When we have a problem statement, the next step is to determine what kind of problem it is, whether it's a classification regression or a clustering or association, anomaly, etc. So we wanted to find out what kind of problem. Based on the problem, you select a model. It could be one model for the same problem. It could be multiple model. We talked about why we need this. We don't know which model is going to perform well in a given data sets. So it could be random forest or it could be logistic regression. So we need to see the model accuracy confidence level for each of the model and see which model performs well. We pick those models. And the framework. So we don't want to read this one more time. So this is also we touched. What are the various steps we do? And in terms of at a high level, how does an architecture look? Okay. How does in a artificial intelligence in a real world, correct? Typically, you have seen data lake. What is it? It's a centralized data platform which provides data. Then make the data available for the model to run. Then you have a predictive analytics. Then you have the model outcome. How do you expose the model outcome? The model outcome could be brought into further detailed analysis, root causes, drill down or up, enterprise reporting in whatever form. This is a 100% real world example and 100% real world example. This is something that we both are working, myself and Durga Prasad are working here. Okay. So what kind of data we need, that is driven based on the problem statements. So this is basically an architecture. What is data validation? We are going to see. What is model validation? We are going to see. All right. So this is the terminology what we wanted to understand. When you go out and working in industry, company like Google or Facebook, any of these tech giants, so they use these terminologies. Okay, people working in this industry, they use the terminology. What is a model? Model is nothing but the statistical modeling tools that what you select, such as random forest, decision tree. So these are all called model. I'm sure you know what's the training, what is testing. I don't need to repeat, but that's a critical step. Okay. So what is a learning algorithm? Learning algorithm is nothing but the pattern that what machine learns on data and creates the hypothesis to arrive a state. Okay. So what we wanted in a given credit card statement, whether the statement is valid or not, or whether the statement is fraudulent or not. So in order to machine to predict that, it has to learn. How does it learn? It learns from the training data. When it learns what it does, it creates a learning algorithm. In a traditional software development, can anyone tell what is this learning algorithm called? In a traditional software development, what is the learning algorithm called? Okay, you can answer in your chat window. I'm watching the chat window. What I'm asking for, in a traditional software engineering, if you are a computer science faculty or a student, or IT faculty or a student, I'm sure you all learned or learning traditional software engineering. In a traditional software engineering, what do you call the learning algorithms? Okay, what do you call the learning algorithms? You know, answer to this one, you know, I know that too. So can anyone tell, please? All right, if you're not sure, that's nothing but your source code. Okay, that is nothing but your source code. So what is the source code? The program that what you write. The program that what you write. So that is what I said. We are teaching students to program. But what happened in industry? The machine creates a program. How does the machine create the program? It's from the learning pattern that what it sees in the data. It learns the pattern in the data sets. Then it understands when I have this in a credit card statement, when I have customer signature, when I have customer card verification, then it considers to be a valid transaction. That is the pattern it learns. Okay. Based on that, it creates an algorithm. That algorithm is nothing but the source code that what we write in a typical software engineering. In a typical software engineering, we write source code. This source code now not expected by a human to code. Instead of human, the machine creates this code. That's the learning algorithm. All right. So when a machine, when you deploy a machine in production, the model produces an outcome. Okay. So what is the model supposed to do? So when I get a new customer, I want to run the model in the new customer. It tells me whether this customer is going to churn out or not. If it is going to churn out and when it's going to happen. So that's the model outcome. Then I have to verify. What is the verification, model verification? At what confidence level the model says this customer is going to churn out? And which is the influencing factor? Okay, which is the influencing factor? So that is also we have to learn. Okay, so the model outcome is nothing but it is not always going to be a prediction. It could be non-prediction as well. Like for example, if you take the clustering, it doesn't predict anything. Okay, in the clustering, it doesn't predict anything. So in that case, it is not a predicted outcome. It's a clustered outcome. It is a clustered outcome. In a reinforcement learning, okay, in a reinforcement learning, so the model arrives at a hypothesis on a trial and error. Okay, the model arrives at a hypothesis on a trial and error. So that's basically to achieve a task, correct? To achieve a task or to solve some task, correct? So the model develops a hypothesis. The model develops a hypothesis. So that is basically the outcome. So the outcome is nothing but what the model produces when you run on a production data. So once the model outcome is done, you can validate that one. Okay. So when model says John is going to churn out in next 3 months, and it tells me the reason, because John looks for product quality, but our product quality is lacking. So John is going to leave. John is going to leave. So that is basically model validation. So when you do model validation, we have different options. Okay. So what are the options typically in model validation people do? Okay. So when you do model validation, so this is based on 3 things. Okay. So you have a model validation. So this is the model validation. Let's take this one. So this model validation, it's based on, okay. So what do you have? So you have model outcome. You have model outcome. So this is the model outcome. So the model outcome creates model validation. You take the outcome and do a validation. You take the outcome, do a validation. So when you do validation, what it does? So it does 3 things. How the model is performing. Okay. How the model is performing. Whether it's a regular performance. Okay. Regular performance. The model is performing regular, or the model is performs under, okay, underperforms, or the model performs over, okay. So this is basically what is model validation does, okay. So model validation is nothing but, so how the model is performing, where it's an underperforms, regular performs, overperforms, okay. So what under, let's say, what is our problem statement? Okay, let's assume the problem statement. Hello?
Screen is not changing, sir.
Screen is not changing?
Yeah, it's showing morning session, afternoon session screen.
Oh my God. Is it for everybody or is just only for some people?
No, sir, everybody.
Let me stop and reshare. I I shared a lot of things. Oh my God. Okay. How about now? What are you looking for? Looking at?
It's a model outcome right now.
Okay. So what I talked about it, I talked about this screen as well, this slide as well. So this is basically what I told, how machine learning application solution developed in real world, correct? So did you got to see the screen or no?
No, sir.
Oh my God. Okay.
So can you repeat that?
Yes, I'm going to repeat this too. So in a real world, like for example, in this particular case, what we are trying to do, we are trying to predict whether the customer is going to churn or not. So in this case, what kind of data I need to predict the customer is going to churn or not? Okay. So what kind of data I need? So the data that I need, okay. So I hope you're still seeing my screen now, correct?
Yes,
So
sir.
are you seeing my, okay. So yes, to predict whether a customer is going to churn, what data I need customer billing information, invoice information, pricing information, customer service, and customer feedback. Okay, this is a real example. So it doesn't matter what business you do, that's what's required. So this data brought into data lake. What is a data lake? A centralized data platform where you can get all the data. Then you perform certain data validation and make the data available. Okay, make the data available. And on top of it, you run a predictive model. So the predictive models predict whether the customer is going to churn or not. When it predicts, it writes the model outcome. When the model outcome is written, it's sent it for further analysis, detailed analysis. Okay? So what kind of analysis you do? If a customer is going to churn out, that means I'm losing money. So what is the impact to my revenue? Okay, and how does my cash flow is going to look like? Why the sales is declining? Like this, you can do different analysis. And you can also do why the customer is going to churn out. We talked about the influencing factors. Correct? What is the influence of our customer to churn out? Is it product quality? Or is it something that customer is not happy with the service delivery, etc. So the next is you can go up and down and drill through all the things. Okay, write a report. So these are the things you do once the model is predicts as an outcome. But at a high level, if you see, so you have data brought into the data lake, then make the data available. That's the data provisioning. Run a predictive model, write the model outcome, and expose the data to the users. So that is how in a real world this works. Okay. So what I was talking about, different terminology I was using. So can anyone confirm what screen you are looking at? So are you looking at the terminology used? So you can put it to the chat window. Okay. All right. So that's fine. So now what we are talking about different terminology used in industry perspective. When people say model, what is exactly the model? The model is nothing but the statistical data analysis technique that what we are using. Those are all models. Random forest is a model. Neural net is a model. Okay. So, and decision tree is a model. So these are all different models we can implement. I'm sure you know what model training, model testing. I don't want to repeat. I already talked about it. Correct? So teaching the machine and making the machine to learn certain things, it's a training. Okay. Once it's trained, then we need to understand how well it's trained and do a testing. It's like how you are teaching a student. You are teaching a student mathematics. 2 plus 2, 4. 4 plus 4, 8. 8 plus 8, 16. So I taught the student. The next day, I'm going to give a test. Okay. So I'm not going to do 2 plus 2. I'm going to give 3 plus 3. So what is 3 plus 3? The student says 6. What is 6 plus 2? 12. So now they learn, they understand the pattern. Okay? So that is what testing. So testing is the confirmation of how well the model is trained. So once that is done, what happened to the model? So model creates an algorithm. Okay? What is the algorithm? And this is what I'm referring. In the traditional software engineering, this is called source code. So there's nothing but your source code. So in the traditional software engineering, what we write a source code. Here, you don't have to write, the machine writes the code for you. And that is why we talked in the first session, the impact to education. So we are teaching student write a code, but the world is right now changed. So student don't have to learn how to write code. Instead, the machine creates the code. So that is the learning algorithm. So what we talked about, model outcome, model validation. Model outcome, it's nothing but when a model predicts what is the outcome comes out. And that outcome you have to verify. So model outcome is nothing but the expected outcome from the model. Okay, whether it's a clustering or it is in a classification problem of true or false, or in a regression problem of range of value, whatever it is, the model has an outcome. Now I need to validate, and that is what I was talking here. So what is the validation I'm going to perform? The validation includes accuracy. Okay, the validation includes accuracy. So the model outcome, model validation. So model validation, how do we perform? Regular perform, underperform, overperform. So how do we do this one? Do this one? It's based on the problem statement. Okay, problem statement. So based on the problem statement, okay, so we will have a model and that creates an outcome. We'll have a model that creates an outcome. So that outcome need to be verified. How do we verify? It is verified based on these approaches: regular perform, underperform, overperform. So what is the problem statement? The problem statement in this case, okay, let's take an example. Okay, what is the Dr. Rangasamy salary? Okay, what is predict Dr. Rangasamy salary 5 years from now? Okay, predict Dr. Ranga. Okay, salary 5 years from now. Okay, 5 years from now. So let's take an example. So the model expected to predict the expected salary of Dr. Ranga. Okay, the expected salary of Dr. Ranga 5 years from now. So what is the regular performance? Okay, right now Dr. Ranga salaries, let's assume 75 lakhs. Okay, 75 lakhs. So if the model regular means the model basically trying to predict. So the model outcome in this case, okay, in this case, let's assume it says 80 lakhs. So that is basically the model outcome. Underperform the model current salary is, okay, the current salary. So let's say current salary. So current salary 75 lakhs. Okay, current salary is 75 lakhs. So now the model predicts 85 as the model outcome. 80 lakhs is the model outcome. So let's say the model outcome in this case 65. So that means it's underperforms. Okay, it underperforms. So the next is overperforms. So let's say the model says in this case it is going to be 1 crore. Okay, it's going to be 1C. So this is basically overperforms. This is just an example I'm saying. Okay, so when you do model validation, you perform a analysis. Okay, whether the outcome that what it came out from the model, whether it's an underperforms or overperform or regular performs, correct? So you have to draw a graph. Okay, when you draw a graph, if anything that falls under, okay, let's say, so this is 75 lakhs. Okay, let's say this is 75 lakhs. So this is 70 lakhs. Okay, this is 70 lakhs. So this is the curve for 70 lakhs, just based on a year. Okay, so one side I have a year and the other side I have salary, correct? So let's assume this is my year. Okay, in what year? This compensation. And here I have salary. Okay, here I have salary. So if I draw a graph, okay, so where does the 70 lakhs, let's assume it comes here. Let's assume it comes here. So now when I float these values, okay, so 70 lakhs is here. Let's assume the 75 lakhs, correct? It's okay. So let's assume the model is predicts, okay, 1 minute. Let's assume the model is predict around 75 lakhs. Okay, so now I'm going to put 75 lakhs, which let's assume that it's coming somewhere here. Okay, it is coming somewhere here. So this is 75 lakhs. All right, it's very close, but it's fine. Okay, it's very close, it's fine. So this is 75 lakhs. Okay, it's coming here. So the next case, it's 65 lakhs. Okay, the next is 60 lakhs or 65 lakhs. So that is going to be here. So that is going to be here. Okay, this is going to be 65 lakhs, something like this. Okay, all right. So here I have higher performance. Okay, it goes 1 crore. Okay, it goes 1 crore. So I'm just trying to tell you, okay, I'm trying to tell you, this is basically representation of the model validation. So you will perform, if based on the model outcome, you will classify where it's a regular performing, underperforming, overperforming. Overperforming, it goes above the expected value. When you know this one, it's the model testing. When you do the testing, okay, these are all happening during the model testing. Okay, during the model testing, these are all happening. So that's when you do. Otherwise, you don't test this one. In a production system, you don't test this one, correct? Can you test in a production system? Can we test this in the production system? No. So when it goes to production, it should function, it should work well. Okay. In a production system, it should function and work well. So if you see you have a problem statement, then you've done all the steps, then it comes to model outcome. Okay. So model test, then model creates an outcome, then you need to verify, you need to validate. So the validation time you do underperform, regular perform, we need to determine how the model is performing. When it's an underperforms, regular performs, overperforms. Correct? So I'm just giving an example. So our goal is to predict how much salary Dr. Ranga is going to make after 5 years. Okay. After 5 years, what is his salary is going to look like? What is his current salary? 70 lakhs. Okay. What is his current salary? 70 lakhs. So if this regular performance, the predicted value could be somewhere close to 75 lakhs. If it is underperformed, it is lower than 70 lakhs. Overperform, it's very high, it's more than 70 lakhs. Okay, more than 70 lakhs. So that is the concept behind what is regular perform, what's underperform, what's overperform. Okay, it applies for everything. So this is how you do testing. This is how you do testing. Okay, this is how you do testing. So what happens if the model is overperformed? Can anyone tell? So let's say the model is right now overperformed. Okay, currently, let's assume the model is overperformed. What to do now? Okay, let's assume. Okay, let's assume the model is overperformed. Okay, the model is overperforming. Okay, okay. In this case, then what to do? Okay, then what to do? Can anyone tell, or at least put your messages to the chat window if you can? So let's assume the model is overperforms. If it performs over, then what can we do? Any idea? Can anyone tell? You can put it in the chat window. So if it is not, that's a big deal. Okay. So these are all you have to think through. Okay. These are all you have to think through. Okay. Go for regularization. Okay. But how does the regularization is going to help? How does a regularization is going to reduce training data? So that point I can buy. That point I can buy. It may not be just reducing training data. Okay. It may not be just reducing a training data. It could be the problem with the feature. It could be problem with the feature. Correct? It could be the problem with the feature, that what the feature is selected. Correct? So that could be a problem. Okay. Just because, yes, these are all you have to try it out. Whatever you are saying, correct? Either reduce training data or increase training data, add more feature, reduce feature, all matters. All matters. So this is called model analysis. So this whole process, correct? This entire process, what we are talking about, it's called model analysis. The whole thing, whatever we are talking here, is nothing but model analysis. Okay, this is nothing but model analysis. So this is basically what we have to perform. So this is the concept behind model analysis. The whole thing, what I have, is called model analysis. It's called model analysis. So this model analysis are let you decide that point. Okay, so if this happens, okay, if this happens, what am I going to do? If this happens, what am I going to do? So option A, change the feature. Okay, so this whole thing, now you do model analysis. Okay, so based on this, what you can do model analysis. Okay, you can do model analysis. So can you all see my screen or not? Model analysis. Okay, can you all see my screen?
Yes, sir. Yes, sir.
Okay. Okay. I'm writing actually, so I wanted to make sure you're able to see the screen. So what is model analysis? It's nothing but someone said increase training data. Okay, increase training data. Okay, increase training data. Okay, so that could be increasing training data. Okay, I can increase the training data or change features. Okay, change features. Okay, change features. Feature is not working. Or so okay, change features or add more feature. Okay, add more features, add more new features, add new features, more features, new features, more features or new features. Okay, new features. So all these things, it's called model analysis. Okay, these are all called model analysis. This is the model analysis portion. Okay, this is called model analysis. So this is nothing but model analysis. Okay, model analysis. So you do model analysis. Okay, model analysis. So that is one of the terminology that we are talking. Okay, you see this one? So that is one of the terminology. So in a real world, you do model analysis. The next one is, it's extremely critical, model pipeline. What is model pipeline? So once you build the model, so typically how model is done, so you have different systems. Okay, you have different systems. Okay, keep in mind as we discuss about it. So what we have, so we have the AI platform. Then the underlying depends on what kind of problem you're solving. So this is your AI platform. Okay, this is your AI platform, and this is okay. This is your data platform. Okay, this is your data platform. Okay, it could be big data. It could be big data. Okay, big data. So the next is underlying. Okay, underlying this, you have a data collections. Okay, data collections. Okay, hold on. So you have data collections. Okay, so the underneath you have data collections. So typically this is your IoT. Okay, typically, not always, typically. So this is your industrial IoT. So that's a data collection. Okay, 1 second. So now what you have, So you build everything in this platform. Okay, so this is my development. So this is my development. So this is my development system. Okay, this is my development system. Okay, so once I'm done, how do we test? You can test here, or you can do to quality system. You have similar system landscape, you can put them into quality. Once the model is tested, everything looks good, then I move on to production. Okay, I move on to production. So what model pipeline will do? Okay, so this is how typical landscape look. You have an artificial intelligence, you have big data, and then the IoT for data collection. Okay, this has to connect. Okay, in a real world, all three must have to work together. Okay, this has to work together. All three must has to work together. Okay, all three is must. Okay, in real world. Okay, in real world applications. So this must have to work together. Okay, this must have to work together. So now what I'm trying to sell, what is model pipeline? So when you say pipeline, okay, the flow from here to here, okay, the flow from here to here, it should work seamlessly, okay, from here to here. So this flow, okay, this flow is the model pipeline. So this pipeline is basically, if you look at Amazon Web Services, okay, you can do Google actually, okay, go to Google, type data pipeline, model pipeline, okay, data pipeline. Okay, so type AWS data pipeline. You see this one? So this is to get the data from wherever it is. Okay, it's a service that's available. So it doesn't matter where your data, you can build a pipeline so that the model continue to train. Okay, so this is a tool that you need to use. And the second thing, okay, so this is the pipeline from top down bottom. And then also you can do model pipeline. This is a data pipeline. You can also have model pipeline. So model pipeline, there are tools available like Kubeflow and Kubernetes. Okay, so you can search on Kubeflow and Kubernetes. Kubeflow and Kubernetes. So this is basically allows you to build the model pipeline. Okay, so these tools, Kubeflow, okay, Kubeflow and Kubernetes, these are all allows you to do model pipeline. So this is I'm going to call model pipeline. Sorry, model pipeline. So why it is pipeline? It's like a water. It's like a water. It is going to flow from start to finish. Okay, it's going to flow from start to finish. So this is my model pipeline. Okay, this is my model pipeline. So this is done using a tool called Kubeflow, and also people use Kubernetes. Okay, you can type Kubernetes. Okay, so this is basically Kubernetes. So that's another thing people use to do this one. And sometimes people also use Dockers. Okay, people also use Dockers. So these are the tools required to build a model pipeline. In order to build model pipeline, what you need. So in a real world, you need to use these kind of, all are open source. You don't have to pay anything for this one. These are all free. Okay, only thing you need to understand. So this is called model pipeline. Okay, this is called model pipeline, where model flows from end to end, both horizontal as well as a vertical. Okay, model can go horizontal as well as a vertical. So this is the model pipeline. Model pipeline. Okay, so it is the final state. Okay, this is the final state. The software typically people use for model pipeline. Okay, it's either Kubeflow or a Kubernetes or Dockers. Correct? So Dockers actually comes with the Kubernetes. When you say comes, it requires a dependency. Kubeflow could also runs on Kubernetes. Correct? To run a Kubeflow, you also need a Kubernetes. So again, I'm not trying to distract the class to go on to these topics. And these are all advanced topics. Certainly we can explore, we can teach, we can study further. But I want you to understand, it's not just only Python. Okay, don't think Python. Python is just a very basic things. Correct? So these are all the another tools you need to build the model pipeline. Okay, as I told you, AWS also offers a data pipeline. Data can go from anywhere to anywhere using the pipeline. All right, so that is one of the concepts we wanted to understand. What is model pipeline? Let's move on. So we understood all the terminologies. The next one, model deployment. So for model deployment, we typically use Kubeflow and Dockers. Okay, so these two was required for model deployment. So how do we deploy the model? Okay, so the Kubeflow for our pipeline, primarily pipeline, and these two tools, which is the Kubernetes and Dockers, are primarily for building the actual model deployment. So how do we deploy the model? Correct. Typically, you work on a cloud infrastructure. Correct. So if you want to deploy this, so for that you have to have these type of tools like Kubernetes and Docker. So we talked and discussed about training data, test data. I'm not going to spend time. Data provisioning, making data available. It doesn't matter what form the data. Keep in mind, it's extremely critical for you to understand. So don't think it's going to be only file-based data. Okay, that's for your learning. But if you want to solve complex problem, real-world problem, then you have to provision the data, regardless of what format, whether it's a structure, semi-structure, etc. That is important. So data validation. What is data validation? So this is looking at the data and verifying whether the data has completeness, accuracy. Data completeness, integrity, and accuracy. Okay, data completeness, integrity, and accuracy. I'm sure you all know about these things. I don't have to go and spend a lot of time on what is this. Okay, so what I'm trying to say. So this is basically how do we verify? Okay, not this guy. How do we verify the data? So what am I going to verify? Correct? I'm going to verify the completeness, accuracy. So maybe you can take this an example or an assignment, figure out. So what is the data validation supposed to do? So here we have data completeness, accuracy, integrity. Okay, data completeness, accuracy, integrity. So that is the data validation. Okay, so check for data completeness. Why do you think we need to check? Why do you think we have to check this one? Why do you think we have to check the data completeness, accuracy, data quality? Any idea? Why do you think we have to test this? Can anyone talk, please? Okay, why do you think we have to test this? Not test, validate the data. Any idea? So one is better prediction. Okay, one is better prediction, no question. So what happened? Let's say how you got the data. So for example, let's say I have credit card statement, but somehow my credit card statement went to Durga Prasad, and Durga Prasad credit card statement went to Dr. Ranga. That is how you mapping done. Okay, the mapping done in a wrong way. So in that case, it predicts Rangasamy based on my data. Okay, it is not the model issue. Okay, it is not the model issue. It's a data quality issue. It's a data quality issue. So the model says Dr. Rangasamy spending this much money, and these are the valid transactions. These are the not valid fraudulent transactions. So same it does for Durga Prasad, and same it does for me. So what happened? Since the data is not validated, so my data went to Dr. Rangasamy. Dr. Rangasamy data went to Durga Prasad. So in that case, it's not an issue with the prediction, it's an issue with the data. So we have to have this process, making sure the data is validated. So then we talked about data pipeline, okay? Yes, see, one is getting more accuracy, but before you go to accuracy, correct? How do you know whether the model is performing? Like, the model is not performing, correct? So it is performing poorly, okay? Let's assume model is performing poorly, but how do you increase this one, correct? So in order to go and test the model, okay, you can continue to test, you can continue to train, it is not going to work. Why? Data itself wrong, okay? Data itself wrong. So in that case, there's no way to improve the accuracy or increase or a better prediction or whatever, right? Why? Because my data is wrong. So my data basically tells me my data went to Dr. Rangasamy, Rangasamy data went to Durga Prasad. So that is how the mapping took place. So in that case, there's nothing to do with the model. The model is doing what it's supposed to do, but the actual issue is with the data. The actual issue is with the data. So that is what we need to fix, okay? Anyway, so you'll understand that part, okay? So part of your teaching curriculum, include all the things, okay? Include all the things, because the student has to understand what is validation, data validation. So definitely it is not for better prediction. The better prediction will happen, but this is, even if you supply any data, it's not going to do the same thing, okay? All right, so now the next one is data pipeline. It's also a critical step. So we discussed data flows from source to the target, correct? Data flows from source to the target. So that's a data pipeline. So if you look at here, so what we have, so we have sources, okay? You have different sources. From there, the data goes into all the way to the model analysis, predictive analytics, correct? If you see here, so what we have talking about, this is what pipeline, okay? This is the pipeline. So I'm just going to take this and put it here. So what is pipeline? Data pipeline. So the data pipeline is nothing but, okay? The data pipeline is nothing but. So this is basically data that flows from source to the target. Okay, data that flows from source to the target, to the predictive side. So this is the pipeline. Okay, so what I'm talking, you build a pipeline. Okay, you build a pipeline. So that the pipeline is nothing but how data flows from source to target. Okay, so this is my pipeline. Do you see this one? So this is the pipeline. So the data goes from here to here. The data goes from here to here. So that is my pipeline. So it comes from the top to bottom as well as bottom to top. Okay, so data flows from above and below. Okay, the data goes from above and below. So this is the pipeline that I'm talking. So this is called data pipeline. Similarly, model, we also have a data pipeline. Similarly, model, we also data pipeline. Okay, it is important to understand all the things. Okay, it's important to understand all the things. Okay, just a second. Okay, so this is the data pipeline. Data pipeline, data goes from the source to the model runtime. Model runtime in this case, it's a predictive model. Model runtime in this case, it's nothing but the predictive model. All right, so let's move on. So these are the terminology I just wanted to make sure you understand. Let's summarize. So you should know what is a model, training model, testing model, learning algorithm, model outcome, model validation, model analysis, model pipeline. Then model deployment, training data, test data, data provisioning, data validation, data pipeline, and traditional approach wise AI. So that we already talked about, correct? Anything? So this is most commonly used. I'm not saying this is the only thing. This is most commonly frequently used terminologies. So we should be in a position to be able to explain to students what it is. All right, let's move on. So the next what we want to talk about, feature engineering. Okay, the next we want to talk about what is feature engineering. So first of all, what is a feature? Can anyone tell, please? You can put your response in the chat window. You can put your response in the chat window. Can you tell me what is a feature? Okay, what is a feature means? In the context of machine learning, okay, in the context of machine learning, what is a feature? A property of an entity, okay, attributes, okay, I'm reading your response, attributes, okay. So again, all definitions, all the things what you're saying here, absolutely correct, no question. But feature is nothing but, okay, feature is nothing but a hypothesis to solve the problem, okay. So that is basically the model has to understand, if I have this, then I would say this is a valid record. I'm just going back what we discussed actually. So when we talked about the type of machine learning, so we looked at different things. Okay, we looked at different things. You see this one? Okay, yes. So this is basically what we call features. If you see here, so I have a transaction ID, transaction date, transaction location, transaction amount, card verified, signature captured, etc. So this is very simplified way you could understand. So these all called features. I'm telling the machine, hey, machine, if you see a transaction ID, transaction date, transaction location, amount, everything is filled up. So that means it's valid, no question. Okay, it is valid. So the machine learns and understands. So what it is, the hypothesis to arrive the prediction or to arrive a state to solve this problem. Okay, all right. The model. If you yes.
Jyoti sir, sorry to disturb you. Go for a presentation mode, sir.
Sure. Okay, so here what I'm trying to tell, the transaction ID, transaction date, transaction location, transaction amount, card verified, signature captured. So those are all features. What it indicates to the machine. So it indicates the machine.
Hello, sir.
Yes, problems?
Presentation mode, sir. Click on F5, slideshow.
I'm in the presentation mode right now. You see now? See this one, presentation mode? See this one, slideshow? Can you see my cursor?
No, sir. Slideshow, slideshow, no.
Yeah, slideshow is that is what is the presentation mode. It's no. I'm in a full screen now.
Not so. We are not getting full screen.
Okay, so let me take a picture of my screen and send it to you.
Or press F5 like.
I can press anything. I'm just telling you, like, I'm in a full screen. Okay, so I'm sending the screen picture. You can take a look. Okay, I send it to you. Take a look. So if you want me to, like you said, you want me to press F5?
Like bottom of the
Sir,
screen is what?
sir, you see the slide share? That is a full screen mode. Now I'm in a full screen mode.
Okay,
So
sir.
let me stop. Let me stop and share again. Okay, let's see if that helps. I'm stop sharing now. Okay, so I'm going back to share my screen. I'm selecting what I wanted to share. Okay, I'm selecting this, share, and going back to full screen. So can you see in a full screen or no?
Yeah, this is what we are expecting. Yes, sir. Thank you.
Yes, I was doing that. It was like that.
Okay, okay. Thank you, sir. Carry on.
No problem. So what I was talking about, feature engineering, what is a feature? Feature, of course, whatever you said is right. Attribute, no question. Data element, no question. But what exactly it means? So it means it's telling the machine a hypothesis to predict something, arrive something. Okay, a hypothesis to predict something, arrive something. So what is the hypothesis in this case? Okay, what is the hypothesis in this case? So hypothesis here, the transaction ID, transaction date, transaction amount, location, etc. So this is basically tells. So you take the first transaction, 101, a date, location, amount, card verified, signature captured, yes. If it is there, it is true. So this is what to arrive. Okay, to arrive this state, I need all this speed. So now we are going to talk about the importance of that. Okay, now we are going to talk about the importance of that. So I'm just giving an example. So the one that what we are going to talk today, the time series analysis, has all those features. Okay, so how did we arrive? So I will explain that one. So this is nothing but feature. All right. So how does the features going to be extracted? So it's going to be based on a problem statement. You know what data we need. Based on the data, we will arrive what feature we need. Okay, we will arrive in what feature we need. Again, it's most difficult job. Okay, because if this is not right, okay, what will happen? So I'll come to this question later. So what happened if the features are not right? So you need to understand the feature controls the model outcome. The feature controls the model accuracy. The feature also controls the model confidence level. The feature also controls the weightage of the model outcome. Okay, when I say weightage, when it says a customer is going to churn out Y. Okay, the Y part is the weightage. Okay, the Y part is the weightage and the reason. Correct? So that is the reason. So the customer is going to churn out because the customer is not happy with the quality and the price. Okay, and the price, both are equally weighted. In some cases, the customers are not happy with the price. In some cases, the customer is not happy with the quality of the product. Okay, so this is basically telling you that why a customer is going to churn out. Why a customer is going to churn out. All right. So the feature is most critical one to understand. Let's understand all these questions. What is the role of feature extraction in machine learning? Okay, so which is nothing but arriving a hypothesis. Okay, arriving a hypothesis. That means for the machine to learn the features, for the machine to learn the patterns in a data set and develop the learning algorithm. Okay, develop the learning algorithm. Typically what we do, if this there, if it is there, then go for this. If it is not there, then go for this. It's so many if else, correct? So many if else. So if you see the credit card statement, so we have if location is there, true. If amount is there, true. If card verified is there, true. So that is so many if. We don't want to put so many ifs. Instead, we can use the feature, the machine learns and understands. So point is, so the role of feature in machine learning, it is to develop, for the machine to develop a hypothesis, which is nothing but the learning algorithm. So the machine creates a learning algorithm, which is similar to your source code with if-else statement.
okay, which is similar to your source code with an if else statement. Why a feature extraction is so important? If the feature is not extracted rightly, okay, if the feature is not extracted rightly, the model will not going to produce an outcome. Even if it produces an outcome, that outcome may not be useful to business. Okay, useful to business. Basically, what it tells you, customer is going to churn because the customer doesn't like product quality. But when you go and talk to the customer says, "Oh, I'm happy with my product quality, but the price is too much. I cannot handle this one." So the feature extraction is so important because that plays a key role in terms of business impact. In terms of business impact, how do we know which feature we need for a particular problem? Okay, how do we know which feature we need for a particular problem? So this is based on your business knowledge. Okay, this is based on your business knowledge, and this is where the domain experts comes into picture. Okay, if you are building a model for a cancer diagnosis, what information I need that we may not know. So we have to work with a subject matter expert who's very comfortable in disease diagnosis such as cancer disease. Okay, so how do we know which feature? There's no rocket science. Okay, it has to be come from a business. So the business is the one going to tell you what it is, but you should be smart enough to understand and extract everything. Okay, that is one point. Okay, so the next is, out of all the features, which feature is most important? Let's say you have 10 feature. So how do you know which feature is most important? Okay, so that is again, it's from the business point of view, you have to tell the users. So you also need to tell the business user which feature is most critical. Most critical. Can we change the feature after reviewing the model outcome? Answer is yes, we can. Okay, answer is we can. The last one, having more features is a good practice. No, it is not. If we have more feature, the learning will take more time. The model may not have better algorithm to be developed. Okay? The model may not have better algorithm to develop. So these are all key important questions for you to understand. Okay, so this is kind of covers all the things what you need to know machine learning at a high level. Okay, again, every topic requires deeper insights, deeper discussion. Okay, like especially the model pipeline, data pipeline, model validation, data validation, all the things requires an in-depth discussion at various areas. But in this type of short-term session, we won't be able to go that far. So whatever we covered, it should be enough. Rest, you can build it up based on that. All right. So now we are moving on to the actual use case, what we wanted to implement. Okay. Time series data analysis, predictive analytics applied in planning, budgeting, forecasting. Okay. I'm sure you all understands what's time series data analysis, no question. I'm sure you also understand what's a predictive model, but you may not know how does the planning, budgeting, forecasting works. Okay. I'm sure from academic side, you know, in a real world how it works. How do you do plan? How do you do budget? How do you forecast? Okay. So that you may not know. Okay. So we have to understand some basics, then we'll move on. Okay. Then we'll move on. So what we are going to do, we understand this, and we are also going to work towards implementing this using machine learning model. Okay, using a machine learning model, linear regression. So we are going to use this linear regression model to implement this one. All right. So let's understand what's the time series data analysis in a real world. So again, it's just a simple way to look at it. So the time series is basically nothing but data represent in a timely fashion with an equal time interval. It could be weekly, it could be monthly, it could be daily, it could be hourly, etc. Okay, so you can represent the data in a timely fashion. Okay, so you can represent your past data, current data, future data. Okay, past, so things that already happened. Okay, in 2014. Okay, in 2014 to 2019, can you give me all our enrollments? How many people we enroll in computer science department, electronics department, mechanical department, etc. So that is basically the data that represent the past data. So the current data in 2020, can you tell how many students we enrolled in each department? That's the current data. Future data, in 2025 or in 2021, okay, how many students we are expected to enroll in math, in a computer science and IT and electronics and civil engineering, all those departments, okay? So this is basically data represented in the form of timely fashion. That could be yearly, monthly, quarterly, weekly, daily, etc. You can represent them, analyze this one. So this is basically what time series, okay? All right. So we already talked about it. Okay, what is past data, current data, and then the future data. So why do we need to know the future data? The future data is the one needed for planning, budgeting, forecasting. As one, it could be for many reasons you need future data. Okay, so for 2021, I need to know how many faculties we are going to be involved and how many students we are expected to enroll. Why? So that I can plan well. So in terms of what? Budgeting. How much budget I need for payroll? How much budget I need for running the lab infrastructure? How much budget I need to do all the things? Okay. So then I do forecast. Okay. I do forecast. I do wanted to hear from you. Can anyone tell what is your definition of forecast? Okay. What is your definition of forecast? There's any idea? Can anyone tell? Yes, the future extraction, when you go to deep learning, it's not required. But as a concept, you need to know, correct? So you can't directly go and start learning deep learning. So when you're teaching for student, you will start a simple machine learning model, which is supervised. Okay, so that's the best way to get started. So if you don't know this, obviously you can build deep learning model without understanding these things, but it remains a little difficult. Okay, so doing something simple, getting your understanding, it's most important. Okay, so in terms of like, in terms of basically going out and directly doing a machine learning, deep learning model, I would encourage this, but it's going to be challenging. So what I'm saying, as a concept, you should know what's feature engineering, how it works. And when it goes to deep learning, this is not required. Okay, all right. So some of you put a response. Okay, it's prediction problem. Prediction. All right. Yes, it's a prediction. Okay, it is a prediction. But what it does actually, so you have a plan. Okay, you have a plan. So what is your plan? Your plan is basically, you are expecting in the month of January, I'm going to have 100 students in IT, 100 students, like, the student enrollment for 3 months. The student enrollment is not just 1 month. It is going to be January, February. I'm just giving you an example. Let's assume the student enrollment is going to be in 3 months. It's going to be January, February, March. Okay, it's going to be January, February, March. It's going to be 3 months. Okay, so those are the 3 months the student enrollment is going to take place. All right. So now I am planning for in January IT and computer science. In each, I'm expecting 100 students. That is my plan. So let's say, when did I do the plan? I did the plan in the month of November 2020. Okay, in November 2020, I planned in January 2021, I'm going to have 100 students in computer science and IT departments. So when I reached January 2021, I don't have 100 students in IT and computer science. Instead, I have only 50 students. So now what happened, my planning? So my plan, it's not right. Okay. So under condition, I'm going to do a forecast. What happened? So now I also planned for February and March. I'm expecting, in February, I'm expecting 50 students. In January, I expected 100 students. In February, I expected, so this is what it is. So let's put in a picture. Okay, let's put in a picture so that you can understand what is forecast. Okay, what you said is right. I'm not saying no to you. Okay, I'm not saying no to you. So let's say you are in 2020. Okay, December. Okay, or November. You are in 2000 November. Okay, so you are doing planning. Okay, so you are doing planning. So this is your planning. So what is the planning you are doing? Number of students going to be enrolled. Okay, number of students going to be enrolled. So I'm going to say, so enrollment, okay, 2021 enrollment, okay, 2021 enrollment, all right. So this is plan, okay. So this is going to be IT department and computer science department, okay, computer science department. So this is basically my IT, this is my CS, computer science. So what I have, so this is the plan, okay, this is the planning I'm doing. So now I'm going to have, so this is going to be my Jan 2021, all right. The next is Feb 2021, because my enrollment is going to be for 3 months. Okay, it's going to be for 3 months, Feb 2021. Then I have March 2021. Okay, then I have March 2021. Okay, March 2021. So how many people I'm expecting in each department? Okay, I'm just giving an example. Okay, I'm just giving an example. How many people I'm expecting? Okay, how many people I'm expecting? So this is, let's assume in each, okay, so I'm going to put each month. So 150, 25. So overall, I'm expecting by March, I should have 175 students. Let's assume I'm expecting the same for computer science department too. Okay, let's assume. So this is basically what planning. So I'm doing a planning right now. So based on my planning, I have these data sets. Okay, I have these data sets. So in IT, I have 100 students. Okay, in computer science, I have 100 students. Now let's say we are in the month of January. Let's say we are in the end of month. So now we are in, okay, we are in the end of Jan 2021. Okay, so now we are in the month of almost end, okay, almost at the end of it, January 21. So what happened? Now plan will become an actual. Okay, so at the end of this, my plan data will become an actual, the actual enrollments. Okay, let's assume we are in the 2021 of 2001. Okay, sorry, 2001. So 2021 of January. Okay, so that is the month we are in. So when I have this month, okay, I'm having this month. So what is the number of student I have here? Okay, for each of the department. So here I have only 50. So what is my plan? Okay, I answer 150. So my plan in this case, okay, my plan in this case. So if you notice 100, but I have only 50. And my plan is 100, I have only 50. So now what is it? I have variance. Okay, what is it? I have variance. So basically my variance is 50. Okay, so this is my variance. I'm doing a variance analysis between the plan and actual. Okay, so this is basically, I need to correct this one. I will do this. So what is this? So this is my plan and actual variance. I'm doing a variance analysis. When I do the variance analysis, so this is my actual. Okay, this is my actual. So when I do the variance analysis, I will have the difference. Okay, so this is my variance analysis. Okay, variance analysis. So I'm doing my variance analysis. When I do the variance analysis, I will know the difference. Okay, I will know the difference. Okay, so I will know the difference. So the difference that what I'm trying to say is basically tells me I may have less student in February and March. Okay, so this is variance analysis. Nothing but the difference between plan and actual. Okay, difference between your plan and actual. Plan and actual. Okay, plan and actual. So this is basically what you have. Okay, plan and actual. Okay, so I'm doing a variance analysis. What happened? I expected 100, I have only 50. What's the difference? 50. So now, based on the variance, I will do forecast for February and March. Okay, because I'm losing almost 50% of the students. Okay, so now what I'm going to do, I'm going to do forecast. So the forecast is nothing but, so now at the end of March, I'm going to do a forecast. Okay, so what is my forecast? My forecast is going to be how many students I'm going to enroll in each month. Okay, so let's say this is for February and March. Okay, so this is forecast. Okay, this is forecast based on the actuals, based on January. Okay, so this is forecast data. Okay, this is forecast. Okay, so understand? So this is forecast. Okay, this is a forecast based on forecast of Feb and March. Okay, Feb and March. So based on January. Okay, based on Jan, I'm doing the actual forecast. You see this one? This is my forecast. So let's assume this is my forecast. How am I doing my forecast? My forecast is based on January data. Okay, so I'm doing forecast for February and March based on this one. So in this case, I'm going to expect 25 students. So here I'm going to expect 12 students. Okay, I'm going to expect 12 students. So what is that I'm doing right now? I'm trying to adjust my plan based on the actual. Okay, if you see here, so there are three things we are talking: plan, actual, forecast. So what am I planning? How many students I'm going to enroll in January, February, March of 2021 for the Department of IT and Computer Science? 100 each, 50 each, 25 each month. Wonderful. So now I'm in the end of January 2021, and this took place November 2020. So this is taking place November 2001. So now, sorry, January 2001. In January 2001, I'm looking at the actuals. The number of students enrolled in IT 50, Computer Science 50. What is the variance? That means difference between the plan and actual. So what is the plan? What's the actual? I have a difference of 50. So only 50% of the students enrolled. The remaining 50% is not enrolled. So now I'm going to do a forecast. So based on what? Based on the January data. So based on the January data, which is the actual, I'm doing a forecast. You see there's a 50% reduction. Okay. So this is basically what typically people do as a manual process. Now we want to automate this using machine learning. Okay. Now we want to automate this using machine learning. So when we say forecast, it is not just a prediction. You have to understand all the things what we talked. Okay. You have to understand all the things what we talked about. So this is what forecast means. Is this clear? So do you all understand? So do you understand what's a forecast? Okay. So now tell me, okay, no voice. Can you not hear me? Can you hear me or no?
Yes, sir. It is clear. No problem.
Okay. All right. So there are a lot of different ways you can do. Okay. So there are a lot of different ways we can do. So we really wanted to go and build a machine learning model. Okay. So I would suggest, like I said, Karan, don't jump into deep learning model. Understand the basic process and framework. So once you understand building a deep learning model, again, it's all falls down to data. Okay. So understanding the overall flow, okay, it's real critical. But you have to teach students, correct? You're not working in industry. So you have to teach students. You also have to go through all the things too, so that student can understand. Okay. All right. Now what we need to do, so we need to understand what is a 6-month rolling forecast. Can anyone tell or explain in the chat box what is 6 months rolling forecast? 6 months rolling forecast. That's what we are going to do. Okay, 6-month rolling forecast. Can anyone tell? Have you heard about 6-month rolling forecast? You can do Google, you'll get to know. So 6 months rolling forecast, what we are going to do right now. Okay. Training. I am not sure what training means. Okay. So anyway, that's fine. Let's move on. So we are going to focus on right now implementing a machine learning model. Okay, implementing a machine learning model to do 6-month rolling forecast. So this is a real example. So we talk actual, planning, budgeting, forecasting. So what is forecasting? Budgeting is so for the time that what is left over. So right now I have a budget for 100 students, 50 students, 25 students. Okay, but that got changed. So now I have to adjust my budget as well. Okay, so that's what budget is nothing but allocating funds. Okay, so these are all what we talked about. Okay, so time series data analysis, how it's represented, and everything that what I explained, it's here. Okay, so these are all basically like the topic what I just talked about it. Okay, all right. So the real world problem that what we are trying to tackle is the 6-month rolling forecast. Okay, 6-month rolling forecast. As I said, it's a real problem. Okay, this is something that reason I picked up. I'm working on this problem. Okay, I'm working on this project, and also it's very commonly used. Very commonly used. Correct. So there's no one organization. There's no one organization in the world says we don't do plan, we don't do budget, we don't do forecast. So that means they are not doing the right thing. Okay. So everybody has to have a budget. To do a budget, so you have to do certain planning. When plan doesn't go the way you done, okay, there's a variance between the plan and actual. Then you do forecast. Okay. There is a huge variance between the plan and actual. You do forecast. So that it's a cyclic process. You start with a plan. Based on a plan, you do budget. So now the plan become a reality. You do variance analysis. Find the difference between what you planned, what's the actual. So the difference is huge. Then you do forecast. Okay, it is not that you always do a forecast only when there's a difference in the variance, when you see a difference in the variance, but typically that's how it triggered. Okay, I'm going to do a forecast based on market condition. For example, COVID-19. Okay, that is a huge impact. So using that as a driving factor, okay, we can do forecasting. We can do a forecasting. So I forgot to talk about one topic. So in time series, can anyone tell what kind of analysis we can perform? In time series, what kind of patterns and analysis we can see in the data? Okay, in time series data, what patterns we can see and what kind of analysis we do. So if you're not sure, I'm sure you heard about it. A cyclic pattern and a irregular pattern, seasonality, correct? So these are the different type of patterns and analysis we do. Cyclic, seasonal, irregularity. Okay, irregularity. So this is basically type of analysis you can perform on a time series data. So I'm sure some of you know all the things what I just told you. Some of you may not. People who have studied mathematics, statistics, and probability, they will understand cyclic pattern, irregularity, seasonal patterns. Okay, so this is what business wanted to discover. What do I see in the data? Okay, what do I see in the data? So that is basically the outcome of the analysis could be happen on your plan data or your forecast data or your budget data or your actuals. You can do any of those things. So in any of this one, you can perform these type of analysis. Okay, so to discover what pattern I see in the data, okay, cyclic pattern, irregular pattern, seasonal pattern, correct? So these are the different type of patterns you can look at it. So that is what business wanted to do. Keep in mind, these type of analysis, you can perform actuals, plan, and forecast and budget. Okay, you have actuals that is already happened. Plan, in the future it's going to happen. Budget could be applicable for both your current actual budget or a planned budget. Forecast, when I see a variance, typically when I see a variance between plan and actual, then I do a forecast. I planned for 100 students, but I have only 50 students. The variance is 50. Now this will impact my next 2 months, my next 3 months, my next 4 months. Correct? Then I do an adjustment to the plan, which is a forecast for the next 6 months. So how does it going to look for the next 6 months? How many students I'm going to enroll, and how much budget I need. Correct? So these are all kind of connected to each other. So going back to the problem statement, what we are trying to do. So this is basically a company wanted to perform a product and product SKU. SKU is nothing but stock keeping unit, the lowest level. I will explain what it is. Okay. At level 6-month rolling forecast are different. Okay. Regions of the business operations. Okay. So across different regions of the business operations. So this is basically the problem what the business asking us to solve. So what are they asking us to solve? How much I'm going to sell this particular product. The product has a SKU, how much I'm going to sell. Okay, where am I going to sell? In a different region. Regions could be North America, Latin America, Asia Pacific, Middle East Asia, Europe, these are all different region. It's a global level implementation. Okay, so they are asking us to, like someone told me, build a predictive model which predicts the quantity that you are going to sell at a product level and a SKU level. Okay, where you are going to sell at different regions. What kind of problem this is? Okay, what kind of problem? It's a regression problem. Okay, why it is a regression? It's a range of value. How many products are you going to sell? I'm going to sell 100 to 150 products. How many SKU you are going to sell? 50 to 75 SKU I'm going to sell. So that's a range. So this falls under regression problem. So what model we are using? Linear regression. Okay, this is to keep it simple. Okay, you can also go for deep learning, but don't go. Understand this first of all. Then we can go. So see how I'm starting. I'm trying to describe a problem. So this is a global company. Okay, let's take an example, global company like Walmart. Okay, global company like Walmart. They operate in a different location, different geography. Right? So Walmart basically, what it's saying, I wanted to build a forecasting solution which forecast, okay, at SKU level, okay, and product level, how much I'm going to sell in the different regions. So this is a problem to be addressed. To solve this problem, I need a model to be used. In order to select a model, I need to know the type of problem that I'm solving. So what kind of problem? Is it a classification problem? No. Is it a clustering problem? No. Or is it a reinforcement kind of a problem? No. So what is this problem, this one? It's a range of value that I'm trying to predict. Okay, I'm trying to predict a range of value. So for that, so what I have a model called regression model. So under regression, what is a simple and easy model to implement? Linear regression. Move on. Okay, there are two things what I want you to understand, so that you have a feel of how it works in the real world. Okay, so when we talked about product SKU and a product, see how it works in a real world. So it's a hierarchy. It is a hierarchy. So you have a product family and a product group, then the product and a SKU. Let's take an example. Product family is a hardware. Product group is a printer. The product is the actual printer, in this case, color printer. The SKU is nothing but the printer cartridge. So you can sell at various levels. Okay, you can sell the actual printer, you can sell the cartridge. You can sell the actual printer, which is basically the color printer, or you can sell the cartridge. Everything rolls up. Okay, whatever you sell at a SKU level, it goes to product. Whatever you sell at the product level, it goes to product group. Whatever you sell at the product group, it goes to product family. So this is the real hierarchy, how the products are organized. Okay, so product family, hardware, product group, printer, product color, product SKU, cartridge, so that you can easily understand. You can sell this SKU, you can sell the product. The group is just a roll up. Okay, family, it's again hierarchy. These are all needed for planning, budgeting, forecasting. This is needed for, you can plan at this level, you can plan at this level, you can forecast at this level, you can forecast at this level, you can forecast at this level. So you can plan, budget, forecast at any level as needed. Okay, at any level as needed. Let's move on. So we also talked about region. Okay, so what are the different regions? So North America is one region. And then under a region, I have a country. Under a country, I have a state. Under a state, I have a city. Okay, so under a state, I have a city. So here I have region as in North America, country United States, state California, city San Francisco. Let's see how it goes. So where am I selling? I'm selling in a city called San Francisco. And what state? That is California. So whatever you sell under this different city, that rolls into the state. Whatever you have the state, that rolls into the country, then it's going to the region. So this is the place where you sell this one. So now our planning, budgeting, forecasting. The example what we chose, 6-month rolling forecast. We still need to understand what 6-month rolling forecast. I think you are still working on it. That's fine. So the 6-month rolling forecast has to happen at any level. Okay, but when I say any level, it could be city level, it could be state level, it could be country level, it could be region level. So you want to understand all the things. So this is what business wanted to implement us. All right. So can anyone tell why did we look at the product hierarchy as well as the location hierarchy, the region hierarchy. Why did we look at that? Do we have to understand that? Can anyone tell? Do we have to understand those? Answer is yes. Okay, answer is yes. Why? That is how you identify the future. If I don't know, then I don't know what it is. Okay, then I don't know what it is. So this is basically required for future engineering. Okay, when we say region, what exactly? Region is collection of country. When you say country, what is country? Collection of state. What is state? Collection of city. Correct? So I have to understand this for me to choose the future. If I select region as my future, then the model won't perform. Why? You don't sell anything at a region level. Okay, region is just a hierarchy. If we set country as a feature, then the model may not perform. Correct? So all the things matters. Okay, all the things matters. So you have to use and see, and also how you get the data. If you keep region as feature, then you have to have data at this level. Okay, anything that happened at this level is what the model is going to learn. So whatever you choose here, that is what the model is going to use to learn. Okay, that is what the model is going to use to learn. All right. So we understood the product, understood the region. So now how does the things go to work in the real world? So you have a problem statement. We're trying to predict the product and SKU, how much you're going to sell in the region, country, and state. So you do prediction. So this is what it is. I'm just trying to summarize here. So you have product and the SKU. That's what you're going to sell. Where you are going to sell here. What we want to do, predict how much you are going to sell. That's all we are trying to do. Okay. How do we implement this one? Okay. These are all the implementation steps. The implementation steps starts from step 1, use an INI file. Okay. So what we are trying to do, implementing the linear regression model. I'm going to implement the linear regression model. So for me to implement the linear regression model, there are steps I have to follow. Okay. The first step is I'm using an INI file. So why do I need to use an INI file? I don't want to hard code anything in this program. So what is the INI file? So let me go there. I hope you are able to see my screen. In case if it's not, tell me. So can you see my screen? I'm in my Windows Explorer. Can you see my screen?
No, sir.
Ekkada?
All right, let me stop and share the screen. So I stop now. I'm going to share the screen one more time. Let's see. Is this the screen I want? Keep flow. That's this one. On time series analysis here. All right, I'm sharing my screen now. Can you see now?
Yes, sir.
All right. So what I was talking about, there are several steps. The first step is in this case, INI file configuration. Okay, this is the first step. So what is the INI file? That's what I'm going. I'm going to my Windows Explorer. If you're not able to see the screen, tell me. So go to time series. Under time series, the same problem could be also done using deep learning. We are not going there far. So now we are going to focus on machine learning, select machine learning. Under machine learning, you see different folders. So there's a folder for INI. There's a folder for model outcome. There's a folder for source code. There's a folder for training data and test data. So this is just to organize in an easy way so that you can understand. So I talked about INI file. Click this INI file and open this INI file. So why did I use the INI file? I don't want to hard code anything in the program. Okay. I don't want to hard code anything in the program. So in the INI file, I have data source. What are the different data source? In the real world, we have a file, we have SAP, we have Oracle, Microsoft, and also Hadoop. Okay, also Hadoop. So here we are just using only file. Okay, it could be any of these things. And it tells you how do I connect to the systems? How do I connect to SAP? How do I connect to Oracle? How do I connect to Hadoop, and etc. This is a connecting parameter. Okay, then the file path. Where is my training data? Where is my test data? Okay, like this. Where is my product quantity, etc. So these are all different paths. Okay, then I'm defining what region it is. Okay, country it is, etc. Okay, so these are all. I'm putting some values here. This I don't want to use in my source code. I want to kept outside in an INI file. So the INI file is nothing but avoid hard coding these things in your source code. in your Python program. In your Python program, you don't have to code. So keep in mind, I'm not writing Python program to solve business problem. Instead, I'm writing the Python program to connect all the machine learning functions and train the machine. Okay, and train the machine. Based on how the way the machine is trained, the machine is going to create a learning algorithm. Okay, the machine is going to create a learning algorithm. So the point what I'm trying to make you understand, the thing that what you see in the INI file, which is basically avoid any hard coding in the program. Which program? The program that you are writing to train the machine. Okay, not solving the problem. Okay, the reason you are writing this all in Python, you are trying to train the machine. Okay, so anyway, this is the INI file. This is the INI file. So it has a lot more information. So, and it also has different, like, sections, and each section is documented so you can understand. Okay, so this is basically the file that is required to define everything for the model to be trained, tested, and deployed. Okay, so I'm going back to my PowerPoint. If you're not able to see, let me know. All right, can you see my PowerPoint? Okay, all right. So the second one, basically what it is, import all the required libraries. This entire thing, all the steps are inside Python code. Okay, all these steps, what you're looking at, all happen inside a Python program. Okay, so step 2, import the required libraries. So what library we are using? Yesterday we studied about pandas, and we also studied about MATLAB. And in this journey, we studied about TensorFlow and scikit-learn. So those type of library, whatever library you wanted, you have to import them into your program. Okay, all the steps. Okay, all the steps are happening inside a Python program. Okay, all right. Step 3, import the training data. Okay, it is critical. So that means somewhere you have to create the training data. In our case, we are using simple Excel file. In a real world, you create the training data based on different data sources. Okay, different data sources. Once I import the training data, then import the time series model. In this case, I'm going to implement the linear regression model. Okay, the linear regression model. Then train the model. Then import the test data. Then test the model, which is nothing but running the forecasting. Running the forecasting. Write the model outcome to a file and verify the model outcome. Okay, write the model outcome to a file and verify the model outcome. Okay, verify the model outcome. All right, so these are the 9 steps. Okay, so the last step is not same thing. So this is verify the model outcome. Okay, verify the model outcome. Verify the model outcome. Okay, and then calculate the revenue and etc. All right, so these are the steps, basic steps we are doing. Okay, so you can ask yourself, when a model is trained, when model is tested, it's ready to deploy. You can save the deployable model, and then as needed, we can re-import them again. Okay, as needed, we can re-import them again. So what I'm trying to tell you, there are some steps we haven't put here, which is definitely a next level of study. So this is a first level of basic framework for you to understand. All right, so how do we implement this one? So let's look at in a live system. Okay, let's look at in a live system. So I hope you understand the problem what we are trying to solve. We are trying to solve a 6-month rolling forecast. So what is 6-month rolling forecast? If your plan doesn't go as planned, I see there's a lot of variance between what I planned and what actually happens. Under such circumstances, I'm going to change my plan data. How do we change? Do a prediction. What is it called? Forecast. If you are forecasting for 1 month, 2 months, 3 months, 6 months, so then the 6th month, it's going to roll. That means you do forecast every month. When you do every month forecast, that is going to give you data for next 6 months. So from January to June is the 6th month. February to July, the next 6 months. Okay. March to August is next 6 months. It rolls, correct? So that is why it's called rolling forecast. You do forecast by every 6 months, for every 6 months. But the key point for you to understand, what is actually forecast? As I explained, you have a plan, you have an actual. It didn't go as planned. The difference between plan and actual is very high. Now, I don't want this to continue for another 6 months. I want to find out how this is going to impact. And that impact is what prediction. That impact could be due to COVID-19. Okay, so why does so many students are not enrolled? It's because COVID-19. No one wanted to come to the campus. They want to take some time off and see how this overall this is going to work. So they really want to figure this out. So that is basically what it is. Okay, that is basically what it is. So coming back to the concept behind 6 month rolling forecast and just a forecast, it's all nothing but providing users analyzing data in the form of cyclic, irregularity, seasonal, correct? So these are the different way you can analyze the data. You can analyze based on plan, budget, forecast, or actual. It can goes anywhere. Okay. Anyway, so now we are going into the dive system. So what I need in this simple example, I need number one, the Anaconda to be installed. So we discussed yesterday. Okay. So once we install Anaconda, you will see this one. It's already running in my case. So let me stop and start, you can understand. Okay. So I'm just going to stop this. Okay, so I'm going to basically start the Anaconda. So if it is installed, you can see, go to your Windows search, you can see the Anaconda. You see this one, prompt, choose this guy. When you choose, it's going to bring the Anaconda prompt, not your command prompt, the Anaconda prompt wherever you install. So it's installed in my local. Okay. Sorry. So I'm going to the root folder. So I can start from here. So the command that what I wanted to launch. So I wanted to launch the Jupyter notebook. You see this one? So this is a command. Okay. So I wanted to launch the Jupyter notebook. Okay. So when I type this command, okay. So I'm in the root folder. So I'm going to type this command. So this is going to launch the notebook. Okay. This is going to launch the notebook. Sorry. So the Jupyter notebook is basically the editor it's going to launch. Okay, so now it's launching the notebook. Okay, so this is not that difficult. You can easily install. So this is launched. This is a folder. When I select the folder, I see faculty development. I have see time series analysis. Can you all see my screen? Can you see my screen now? Okay. Can I assume you're all able to see my screen? All right. So let's move on. So it looks like you are seeing my screen. That's fine. So now what I want to do, I want to go to time series forecasting. So that is a folder. These are all folders. I'm going to this folder, time series forecast. Here I have machine learning model, deep learning model. I want to go to a machine learning model. So here, the structure what we looked at, I have an INI file, I have model outcome, I have source, I have test data and training data. Let's understand what is our test data is going to look, what's our training data is going to look. Okay, I'm going to open this one. So I'm launching an Excel spreadsheet. Okay, I'm launching an Excel spreadsheet. So I'm just trying to open this one. In case if you're not able to see, let me know. I'm in the Excel spreadsheet actually right now. So sorry, I'm just going to the actual folder AI, time series, machine learning, and this is basically the training data. I'm going to open the training data. Okay, let me also open the test data so that we can discuss this one. Okay, so I'm going to open the test data as well. So this is the test data. I'm going to the test data folder and select this one.
So let's understand. So if you look at, this is my test data, then I'm going to the training data. So if you see the training data, on the top it says the training data, you can see my cursor. So if you see the training data, whatever we discussed in the PowerPoint, I have everything. I have a region as one of the feature, country as a feature, state as a feature, city as a feature, product family is a feature, product group is a feature. So all the things what we talked about, that's what the business wanted. Then I have the actual product. What is the product? Then I have the actual SKU. Then you see the time, year, month, time, correct? So I have this time series. Then this is what the labels, okay? If you notice, these two are labels. So this is nothing but the model is basically, it's going to predict. Okay, that's the label, the model is going to predict. And these data that I kept it here to tell you. So even if you have an extra data, it doesn't matter. You can control programmatically. If you don't want this to be part of the feature, you can ignore. Okay, this is not going to be used actually. Okay, this is not going to be used. So if you look at the actual labels, which is basically what the machine learns. Okay, so what we have, it's a simple supervised machine learning. It's a simple supervised machine learning. So what the machine learns in this case, it learns how much quantity you are selling. Okay, how much quantity of the product, how much quantity of SKU you are selling. Okay, so that is basically what the machine is learning here. In a country, in a region, in a country, in a state, in a city, you are selling product family, product group, product and SKU. It learns and understands for month, year and month and time, what quantity you are selling. Okay, both product and SKU. So this is basically what the machine learns. So this is an extra field. Okay, this is an extra field. It's not there. And the last two columns, this one, it's not there. So this is basically what the machine learns and develops the hypothesis. Okay, in India, city, state, Telangana, city, Hyderabad, how much product I'm selling, how many printer I'm selling, how much SKU I'm selling. So the machine learns and understands. Keep in mind, these are all your actuals. These are all your actuals. It learns the actuals, correct? I hope you understand what actuals means. Okay, so now based on this actual, the machine is going to predict for 6 months. So that is a 6-month rolling forecast. Okay, from whatever month you are in. So now we are in July. So from August, it goes for 6 months. Okay, it goes for 6 months. So it's going to predict this one. So this is your training data. This is your training data. So I'm just going to close this. Okay, the next one, what it is. So this is going to be the test data. You see the test data, it has everything, very much everything, except the label. The label is not there. Okay, you see this one? After time, okay, I have year, I have month, I have time. So after that, I don't have the quantity that has been sold. The labels that what we had in the training data, in the test data, I don't have this one. And that is what this is going to predict and run. Okay, this is going to predict and run. Okay, so we understood the training data, we understood the test data. So now let's go into the code. I'm going to the code. Okay, so this is basically the Jupyter Notebook is launched, it's running. So I'm going to the code. So now we looked at the training data, we looked at the test data, go to SRC, that's a source. And this is basically the actual Python code, which has all the steps what we listed, it's here. So every step what you looked at in the PowerPoint, it's documented here. Okay, step 1, the INI file. Okay, import config register parser. So this is to parse the INI file. Okay, and the next one is operating system commands. There are certain environment variable we're using, so that we are reading from the operating system. So this basically parse the INI file and gets the data. Example, file path and etc. All the things it gets. So once step 1 is done, the next step is import the required libraries. So these are the required libraries. We are using pandas, we are using NumPy, we are using scikit-learn. You see this one? So I'm importing all of those libraries. The next is import the training data. Okay, so I'm trying to get the training data. So this block of code, it gets the training data. Okay, it gets the training data. So once that is done, import the model. What model we are using? Linear regression. From where? Scikit-learn. So this is a model. Okay, you see war model, that's a model. And it is a linear regression model. Okay, where does it comes from? It comes from scikit-learn. You see this one? Scikit-learn. So this is a model. You see this one? Linear regression. That's the model I'm calling now. Okay, so this model has been imported, and that is what it uses. So I'm going back here. So this is basically, sorry, import the linear regression model, this one. Now I do the training data. So I have already fit the training data. The fit function is basically does the model training. It makes the model to learn and creates the learning algorithm. So once the model is trained, then I'm doing a test data. For that, I need the test data to be imported. So once that is done, then I'm going to do the actual testing. I'm going to run the forecasting. The 6-month rolling forecasting, it's been performed here. So you see this model predict, that's what it does. Okay, the model predict is what? Run the 6-month rolling forecast, in this case, the loop. So once it's done, it writes the model outcome to a file. Okay, then this is basically the model predicted outcomes and etc. Okay, so there are other functions which is you may not need this one, you could ignore. So like calculating revenue and calculating like the other things, you could ignore this one. Okay, so this is the actual source code. It's like I said, whatever you see in the PowerPoint, it's here. Now let me delete the actual outcome file, model outcome file, so that we can run and see. Okay, so I'm going to go ahead and delete the model outcome file. So I'm going to file and open. So I'm going to the specific folder. I hope you are able to see my screen. I'm going to model outcome. So it predicts 6-month rolling forecast, and it also predicts the SKU level and a product level, and it calculates revenue. Okay, it calculates revenue. So based on the quantity what you're saying, unit price, it calculates what's the revenue that you're going to make. Okay, so for those months, what is your revenue is going to make? So I'm going to delete these files. Okay, I'm going to delete these files. All right, so that when I run this one, the model get create this one. So I'm just going to delete, and we will see. Okay, it creates all the files. So this is where it stores everything. So I deleted everything. When I go back to the folder, there won't be any files. Or I can see from here. So go to Windows, browse, and I'm going back to the model outcome folder. There's nothing here. Everything has been removed. All right. Now, how do I go ahead and test this one, run this one? So I hope, 1 second. All right. So I'm going to run this one. So before I run, I want to reset everything. Okay. So that everything looks fine. So how do I do? So I'm just going to go to, when you're working in a Jupyter notebook, you will understand. Jupyter notebook is like an editor where you can type this code and run and compile everything. So go to kernel. Under here, you see this option, reset, clear output. Run this one. So that is to make sure everything is clean, it looks fine. So once this is done, then I'm going to run the model. Okay. So I'm not going to run, I can run each cell. Okay. I can run each cell, I can run the entire code block. So go to kernel and then run all. Select run all. It's going to restart and run all the cells. Each one line is going to represent a cell. Okay. Each one of the line is a cell. Run this one. So this may take few seconds. Okay. One or 2 minutes, not few seconds. But you can see here, what you can see here actually. So on the top, if you see, if there is a star, it tells you that the model is running. Okay, if it is not, it's done. Okay, if it's not, it's done. So, okay, 1 second. Okay, hold on. You see the star? That means it's running. Okay. All right. So now I can go and look at the model outcome. Okay, it gives an error. I am sure why the error is coming. Let me see if I can fix it. So that's because of this one, I believe. I'm going to delete this one. I'm going to save this file because I put a label and it doesn't tell what position to read. So it assumes the first column is the label, then it is the column header, then it goes from, that's where it gives an error. So now I'm just going to run this one, go to kernel, reset everything. All right, so that is done. Then I'm going to run the entire program. So restart, run all cells. Hopefully this time works. Yes, so it's still running. You can see the star. You see this one? It's creating outcome. You see this one? Country, region, state, and etc. So it's because I put the extra line on the file, it cost plus one. So once I remove this one, it's working. It's wrote the outcome into the outcome folder. And this is basically the outcome is printed here. It calculates the revenue and tells this one. All right, so now I can go back to the folder, the outcome folder. So I'm assuming you're able to see my screen. So go to model outcome. So now you can see all the files. You can see the timestamp. Okay, you can see the timestamps. So this is the model outcome. It came in a different form. One is 6-month rolling forecast. One is it's a prediction. It predicts for the 6 month. The next one is it calculates the revenue. The next one is it calculates the revenue. Then it does all the things. So how much quantity you sell, how much SKU you sell. Okay, so it writes everything into this one. You can open the 6-month rolling forecast and see what it has. Okay, so it has everything, and it also has the unit that you're going to sell. So let me open from here. You can see the product and the SKU. So these are the two columns. Okay, the forecasted column, it calculates, it predicts, and writes into the file. The rest everything we already seen. Region, country, state, city, customer, ignore customer, and in the this is basically the product family and product group, product, SKU, year, month, time. Ignoring item count, ignore unit price, ignore. Those are all extra field we added for the revenue calculation, and this is the actual outcome that's produced. This is the actual outcome that is produced. Okay, so this is how the end-to-end process works. Again, this is for learning purpose. Okay, this is just for learning purpose. But in the real world, this is quite intense. Okay, how it is intense? This is how the architecture. Okay, this is how the architecture. So we have data coming from different sources. Okay, it comes from device, it comes from SAP, it also comes from network files. Why? It's a global company. You see, it's a worldwide operation. So some country, some places that use SAP, some places that are using file. It also stored in a device level. You connect and read. So that comes into that is processed using Kafka into Hadoop file system. From there, it goes to the model engine. The model engine built on Alexio, Spark, and Zeppelin. Okay, so this is coded using Python and Scala. Okay, and we use deep learning model as well as a machine learning model. The TensorFlow covers both. Okay, then we also use Spark for the distributed data processing. Okay, so this is the real world. Okay, this is the real world, and how the data flows in the real world actually like this. Okay, like this. Okay, so there is a Kafka which connects source to the HDFS, then Alexios comes to the Spark. Like this, data flows from each level, and this is some explanation about each of the technology that has been used. So what is used for SAP? HANA. Okay, that is for data source. That's where data comes from. Okay, Kafka, live data streaming. Okay, to read real-time data. HDFS, data to be stored in a persistent stage. Alexio, in-memory data store. Spark, distributed data processing.
AL model, okay, that's the Python TensorFlow Cafe, correct, and Spark ML. So Python and Scala as a distributed programming, as the microservices. Zeppelin, it's for rapid development, rapid design and development. Okay, so this is in a real world scenario. Okay, we didn't use all this in the session. We just used a file, but it gives a clarity and view on how it works. All right. Any questions? So I'm done for today. If you have any questions, please let me know.
So all the participants are allowed to ask any questions. I given the permission to unmute yourself. Unmute yourself and ask your doubt.
Sir. Sir Jyoti sir, good morning.
Good morning, sir. How are you? For me, good night. It's 11:30 in the night.
Oh, sorry sir. I
No,
don't
no,
know.
no, sorry, no, sorry.
Sir, I have one question.
Yes, sir.
Sir, could you please give a demo on how to resolve the overfitting problem?
Sure. I don't have a demo ready-made, but I can build one, show you.
Okay, thank you, sir. Thank you.
No problem. So, Durga Prasad, can you make a note? We have to, we have to do some groundwork. We'll try to do it tomorrow if we can. If it is not the one other session, we'll do it.
Good afternoon, Jyoti sir.
Yes, ma'am.
Sir, I'm Sumitra here. That was a very informative session, and the way you were explaining was extremely good. So, sir, just one clarification.
Yes, ma'am.
While doing the feature extraction,
Yes, ma'am.
and you were saying that if you want to increase that accuracy of the prediction, we can increase the training set. That is one way. But see, there are certain ratios that we follow when we select the training set data and the test set data.
Yes, ma'am.
80, 20, 70, 30. Like
yes,
that.
ma'am.
So
Yes,
if you simply go on increasing the training set, will it not result in overfitting?
Answer is in my real world example, ma'am. Increasing training data has no connection to future. Future is your direct correlation with the business. You see this one? So it is not going to, increasing training data is not just going to impact anything on the future side. So two things important. One is model prediction accuracy. One thing. Model predicts wrong. Okay, as I said, correct? The model, when the model predicts wrong. So for example, so let's say Durga Prasad. What is Durga Prasad annual salary? 50 lakhs, correct? But the model predicts, we know for sure, I'm using a test data. Durga Prasad as a test data. But the model predicts as 35 lakhs, okay? So in this case, how do we troubleshoot this one, correct? So you may not know whether the future is the one causing this problem, okay? You may not know this one. So you have to try every step. So the first step, like you all told me, change the training data or give more training data or give a different set of training data. Instead of giving more data, I have 1 million record. Okay, this 1 million record belongs to a specific time frame or a specific conditions. But now, even with the 1 million training data, the model is not predicting. So the issue is not with the volume of training data. It's something else. What is that? So now I'm going to look what you said, the training data, test data ratio. Is it 80-20 or is it 70-30 or is it 60-40? I'm going to see that. That is also I tried, it's not working. Still the model is continuing to predict Durga Prasad's salaries, even though he's getting 30 lakhs, it says 15 lakhs, okay? It is not working out. I changed the training data. I increased the training data and test data ratio. Still it's not working, okay? I also went ahead, tuned the hyperparameters, which is if it's a random forest, the number of trees, the number of leaves, I changed those things. But still the model is not working. Why? It could be the future by itself, okay? The future, what you chose, it doesn't have good quality data, okay? So one of the feature, you have a region. What happened? In some cases, the region says North America. In some cases, the region says Germany. That is wrong. That is wrong, correct? So now it's a data quality issue. So like this, you have to try all different combination to arrive. There is no hard and fast rule. You do this, you're done there. That is why it's called data science. Okay, you try with a different combination of data sets, different combination of features. Then you arrive. This is what's working well, and that is why this is more of a research work. Correct. So a very intense research work with a heavy focus on business. I hope this makes sense to you, ma'am. Is it clear?
Yes, sir. So, sir, basically, sir, unless or until the model gives us the expected result, we have to again go through that entire cycle once again.
Exactly.
Okay.
Exactly. Yeah, you wouldn't know whether the problem is the training data, or the problem with the hyperparameter, or the problem with the future by itself, or the problem with the data quality. We wouldn't know this. Okay.
Yeah.
So that is why we have to go through all this process.
Yes. Thanks a lot, sir.
In 99.9% real world, it's the feature and the actual data qualities. That is what the causing problem in a real world. 90% of the time, what I learned, the feature selection is wrong. The data that what has been supplied is wrong. So that is why we put data validation, data completeness, data accuracy, okay, data integrity. Those are all need to be checked.
Okay, sir. Thanks for answering the question.
No problem.
Hello, sir.
Yes, ma'am.
I would like to know, like, what is the suggestions regarding number of features and number of observations?
Sure. The number of features and number of observations, correct? There's no direct correlations. Okay. Can I know in what context you are asking about observations, number of observations?
If number of features are more, we have to collect the more data.
That is not right, ma'am.
That's not right. There is no relation.
No.
If one or two features are there, we want to build a model. There can be a less number of observations. But in case of more number of features,
can you define? I don't want to assume anything. Can you define observation? What do you mean by observation?
Number of rows.
Okay, the number of rows is nothing but like the volume of data that you're talking, correct?
Yes.
So even for two features, you can have million record. Okay, so the features are. Let's take an example. I'm trying to predict whether the given data represents male or female. Okay, you're going to see with the Durga Prasad. So I have only two features, the height and width. Okay, the height and weight. So the height and weight basically is the weight and height of a male, weight and height of a female. So if you see here, I have only two features. The number of record that I have 1 million. Is there any correlation between the feature and the number of record? Answer is no. The feature is basically used to build the hypothesis or understand the pattern. The number of record, combination of pattern. Okay. So what are the combination of patterns? Height is 100 centimeter, weight is 140. That is one combination. There could be, let's say in a million record, there could be 10% of people who fall under this category. Height is 113 centimeter and weight is 200 lb. I'm just giving examples. So there could be number of people falls under this one. So my feature is only two field, which is height and weight, but the number of record is almost 1 million. So is that going to change my model outcome impact? Yes, it can. It could be both. It could be the number of record what you have, that is not in a quality form. Okay, that may impact the model prediction and accuracy. Or the feature itself wrong, correct? So the model is still not learning based on a height and weight. Okay, so it could be anything. But what I have seen in the real world example, the feature selection has a significant impact in terms of what I explained to you. The weightage of, like, it is not just prediction, madam. We have to justify. If I am saying this candidate is going to fail, then I need to justify why this candidate is going to fail. Correct?
Okay.
Without justification, that is meaningless. Correct? So the student is going to fail because in last 4 semester,
he never got anything. And looking at his attendance, he's always absent. Looking at his behavior, he never, behaves well with the students. By considering all the factors, the student will fail. Out of all this one, what is the reason the model says it's going to fail? Is it attendance, or is it the grade that gone through so far, or the behavior in the class, which has the highest influence? That is the feature, and that is what business wanted. They don't want just simply saying the student is going to fail. They don't take it. Okay, they don't take it. So we also have to justify why I'm saying this. Correct? That is the reason for the prediction outcome. Correct? So you have a predicted outcome, you have to have a reason. So the future answer the question of why the student is failing. Okay, a good future should answer why the student is going to fail. It could be attendance, it could be behavior, it could be grade. Out of three, which one is highest? Okay, so that is important. So the second point, the prediction accuracy, not the influencing factor. The features are influencing factor. The prediction accuracy, yes, the student is going to fail, but my confidence level is very low. It's only 60%. Okay, but I want to increase the confidence level from 60 to 90% or 95%. How could I do this? That is when the training data could be a role, or the feature could be a role. We have to figure out. We have to figure out. Does that make sense?
Okay. Actually, like I heard somewhere, like if a few number of features are there, it is irrelevant of how many observations are there. But if more number of features are there, if we don't have enough observations, then model could be not perfect like that. I heard somewhere, that's why I asked.
Sure, ma'am. Again, these are all theory, but when you work on a real world problems, the scenarios are completely different. Okay, the scenarios. So the number of features driven only by business. There's no way you and I can decide what feature it is. For example, when we start building model, I have 10 features. Okay, but when I test the model, the business says, I don't think this is right. Why? So the model tells the customer is going to churn because of this issue. But this never happened in our business. Okay, they will tell you. They will tell you. So whatever you are saying, those are all people may think this, thought this, etc. But in a practical problem solving, the number of features, it's driven based on business for sure. For sure. The having more number of feature, which makes very difficult for model to learn. Okay, and that is why people say the more feature will have more hypothesis pattern to learn. It takes more time. It doesn't matter. You can also give more data. Okay. Technically speaking, there is no such correlation. The features and number of records. Okay. Okay. There is no features. There is no correlation between the features and number of records. Okay.
Okay.
These are all a way to solve this problem. Correct. A way to solve this problem, either increase number of feature or increase number of rows. Like this, you try it out. Okay, see what state you are going to come down.
Okay.
But ultimately, I want you to understand, whatever we build, the business users has to review, test, review, accept. That is when the model is working well. If it is not, it's just learning process. That's it.
Thank you, sir. Thank you.
Yeah.
Sir, I have one more question. It is, if we have more number of features, the feature selection become very crucial. It is become complex. So at that time, what we have to do to make feature selection more effective? Then how can we overcome that problem?
Sir, this is where the domain knowledge comes into picture. Okay, this is where the domain knowledge comes into picture. So, for example, I told you this is my real project, correct? So what I told you, this is my real project. So they told us to do many things. I'm just giving you one simple example. So predict when the customer is going to churn. Is it going to churn in the next 2 months, 3 months, 6 months? Okay, predict that. So that's all they told me. When I have the predicted outcome,
I gave it to them verified. It's everything wrong.
Oh.
If you see underneath,
तो क्या करूं?
I'm using billing data. Okay, what billing that we are doing with the customer, and what is the monthly invoice? In the invoice, what kind of product we are trying to sell, and then pricing. What is the pricing of each of the product that we are selling to the customer? And then we have a service, how the customer has been serviced, correct? So, and then also I have customer feedback. They call and give a feedback. So if you look at this is a high level data. When you go each of this, there is so many fields. Okay, which field I need? So if you are familiar with the SAP has a table called Mara. Okay, that's a material table. That has 120 fields, one table, correct? So in my example, I have a hierarchy, which is product family, product group, product SKU. That comes from too many different tables. If I combine, there's about 500 fields. So how do I know which field is? And that is where your domain knowledge comes into picture, business comes into picture. So from learning point of view, we can randomly fix some features and try it out. Even if it doesn't work, it's fine. At least as a concept, it works well. But when you want to deploy this in a real world, the business user has to accept. They have to sign off so that your model is performing well. They will go with all business scenarios behind the scene. They will try to run this one, correct? They will change your customer behavior and run the model, see how it predicts, correct? I was telling you, Durga Prasad's salary right now, 30 lakhs. The model predicts 25 lakhs. Whatever I do, even if I increase, it's still not doing the right thing. Then I found out it's a data quality issue. Yes, ma'am.
Sir, I just wanted to ask you two questions. One is that how you check the feature relevancy. I mean, what are the features? You have, let's say, 100 of features. Okay, and how to check those? I mean, whether those features are relevant for your model or not. And second,
so in my case, ma'am, I work with the business users. You see this one, I have business people involved, so I work with them, correct? So we will work with the business. See this one, deeper business skills. So I work with the business people to do model selection, correct? So during the model selection, we will also define the features. Okay. So answer to your first question, there's no science, there's no magic. We have to work with the business if we are not sure what the business behind the scene for this, correct?
Okay, and one more thing, I mean, whether you have to consider your, I mean, in your customer chat prediction problem, I mean, seasonality, I mean, have you considered any seasonality?
So this seasonality is always there. Okay. So what does that mean? The seasonality part comes do analysis. It is not a prediction, correct? So when I do the model continue to predict, like, you know, I'm giving a 1 million customer. So the 1 million customer has been predicted, yes or no? Yes, they're going to churn. They're going to churn in the next 3 months. Yes, they're going to churn within 6 months, etc. So I have the model outcome. I'm telling you how we are doing. So now the model outcome is written in a file. The user is going to do analyze. They're going to analyze the data and see what pattern it is. Is it a cyclic pattern? It always goes ups and downs. Okay, I have 6 months of churn. So starting from January all the way to June, I see who are the people going to churn out. So what is the churn rate in January, February, March, April? So now
have you considered this seasonality concept in your model? I mean, while deciding the model.
So designing the model, the seasonality is considered. Answer is no. Okay. So I do seasonality analysis, correct? So there's a time series model that I use to analyze the data. So keep in mind, the prediction is different. Analyzing data on a seasonality is different, okay? So the analysis of seasonality comes on a time series. When you have a data in a time series, there you can apply. You can use ARIMA model, okay? So there's ARIMA models. You can use those models to perform seasonality type of analysis, correct? So you can predict.
ARIMA is also used for the prediction. I mean, like logistic regression or linear regression or ARIMA, autoregressive model also, it's used for prediction.
Madam, using model for what purpose is what I'm talking, correct? Using the model for what purpose? So first model is, keep in mind, in a production, it's not a one model. We have more than, like, you know, more than 50 model running. Model 1 outcome will go to model 2 as an input, which is going to train. Okay, model 2 will go to model 3. So there will be so many different models. It's not just one model you run, correct? So the first part is I have to predict whether the customer is going to churn or not. In that, do I need any time series or ARIMA models? I don't need that. Okay, there's nothing to do with that time series there. So this is, I have to understand whether the customer is going to churn or not. So now I have a predicted outcome. So that I want to apply time series. So what is my time series going to do? So within first 6 months, how many customers are going to churn out? And how do I see the patterns? Correct? Is it a cyclic pattern? Is it a regulative pattern? Okay, so like that. So what you are talking about, your forecasted prediction, correct? Your forecasted prediction. I'm trying to forecast, correct? So at the time, I want to predict. Okay, so that prediction is different. Here I'm talking about a customer is going to churn out. Based on the churn, I'm going to do a time series analysis, right? Based on the churn that I'm going to do. Why? So that has an impact to my revenue. Why? If this many number of customers are going to churn, what is my revenue is going to look like? How much revenue I'm going to lose? I want to predict that, correct? So my churn rate is 2%. Under a 2% churn rate, what is the predicted revenue for me in the month of January, correct? So that is when I use time series. That is when I use ARIMA type of model. Does that make sense?
Good evening, sir.
To ask any clarifications? Still anyone?
Hello.
Yeah.
Sir, hello.
Yes, ma'am. I have 3 more minutes. Yes, ma'am.
Sir, I'm Samiksha here.
Yes, ma'am.
Sir, when would my name number come?
The thing is like I don't have any question as such, but I would like to thank you first for a wonderful workshop. But the thing which I have a request, when you are explaining the code, immediately after that, if we get the code and hands-on, if we do, it will be better, sir.
Oh, sure.
Sir,
so you want
I
the
do.
source code?
Sir, I do have a question.
Yes, ma'am.
Sir, I am Neelam Rawat from KIT Group of Institutions. Actually, I do have a question. As you have said, initially we need to select random features or whatever the domain knowledge we do have. On that basis, I need to select the features, right?
Yes, ma'am.
And I need to know once I have selected the features, a hypothetical features it is. So how to validate feature? What is the validation framework for these features?
Sure.
So is it any
is...
validation technique available there, or we need to just do by try and error or check the results? If the results are coming as per my expectation, then I would go for it, or then again do it. So is it a kind of trial and error method, or there are some validation framework for such kind of selected features?
Wonderful question, ma'am. Actually, the first part of the question is like, model feature selection, correct?
Yes,
so that is absolutely 100% based on your industry knowledge, domain expertise. There's no other substitute for this. There's no other substitute for this, correct? So I'm going to diagnose for a disease of cancer. So under the disease cancer, correct? Under the condition of disease cancer, what are all the symptoms I'm going to look for? There's no way you and I know this. That is a feature, correct? The symptoms that what we need for a cancer patient. So that is a kind of feature. Do I know? No. Why? I'm not a medical doctor. You are not a medical doctor. So we may not know this one. So that is when we have to work with the subject matter expert in that space and ask right intelligent question and counter them, correct? Counter them. So that is the only way to build right feature. There is a role of data scientist and there is also a role of subject matter expert in the domain. So they both has to work together to come the right one. The second part of your question. Yes, ma'am.
So that means I need to play the role of analyst also.
Absolutely.
So if I am working on some data, I am working on some feature results, then I need to be analyst also. I need to participate in such kind of interactions for getting more domain knowledge as well.
Definitely, ma'am. Actually, if you see the type of skills that what we need, correct? One of the topic that we discussed in the class, correct? So probably in the first day. Okay.
Yes, sir.
So I put business skill. From learning, for us to teach and learn, we don't have to go that far. But if you are really working on a real projects, no question, that is a must and mandatory skill. Okay, that is a must and mandatory skill. So you have to understand the business domain. There's no doubt, there's no question. Okay, I'm just trying to go to the slide so that we can discuss. So this is the slide I'm referring. Okay,
Yes,
you
sir.
see, the first one is industry business process. Okay, this is what drives the future, not the model outcome. Model outcome comes later. Model outcome comes later. So I'm trying to answer the second part of the question. There's no trial and error here. So everything, you may not have an industry standard processes, like we have industry standard processes like DevOps, Agile, correct? Like this, we don't have an industry standard way of
Yes, sir. Yes, sir.
collecting model, an industry standardized way of understanding the features and model outcome and etc. It's still evolving, but all I can tell, it is not trial and error. Okay, so the trial and error part will not come to you. It will be with the developer or a data scientist. Okay, so they are the one continue to work with the model, figure out what feature works well, what combination of training data works well, then arrive a state, then give it to the business user for testing. They will create different scenarios. Okay, they will change the test data, they will run the model again, and then they will perform. So I'm going to ask Durga Prasad to show you, we have a way to run these things in the web. So I will ask him to see if he can show you so that you can understand. So basically what it is, you run the model, change your test data, change your training data, rerun the model, etc.
Yes, sir.
You continue to play this one. So that is part of the data science job, correct? You continue to work on data sets. You continue to perform changes to the data sets so that you understand how it performs.
Jyoti sir.
Yes,
Okay, sir. Thank you so much, sir.
Thank you, ma'am.
Hello,
Can
sir.
I ask,
Yes,
can I
ma'am.
ask a question?
Hello, sir.
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Hello, sir.
Yes,
Sir,
I can
this
hear
is
you, ma'am.
Swapna from Sridevi College.
Yes, ma'am.
Sir, this one is very informative session. Sir, which model is best for crime forecast in particular area?
Which model is for what, ma'am? What
Sir?
question? Crime forecasting.
Yes, sir. Is it linear regression? Yes, sir.
So
In particular area.
Sure. So crime forecasting, I have to little bit understand when you say crime forecasting, the number of crimes occurs in a location. Is that what it is? Like for example,
yes, sir.
in
Yes,
the city
sir.
of Hyderabad, we
In
have
a particular
thousands of
location, number of crimes maybe.
Yeah. Yes, you can use that linear regression and try to. I would go on a deep learning. Okay, I would go deep learning models. Then because you will be dealing with large volume of data. Because it taken as example Hyderabad as a city, there are so many streets, there are so many places. Okay, and again, to arrive the number of crime may occur in a specific location. So that means you have to see, like what are the data sets you need. The event that already occurred, what type of event it is, when it occurred, why it occurred, you have to have all the things. So that means the volume of data is going to be huge. Okay, so the linear regression should also work.
Okay.
But I would go with the deep learning models. So that would be best fit. So I could use RNN type of model where I can use complex data sets and figure out. So that's my best guess. But we still need to understand the type of data that we are going to use to figure out what the number of crime rate is going to be in a given location.
Good evening, sir. Sir,
yes,
while doing feature extraction,
thank you, ma'am.
While using feature extraction using neural networks, we are getting the output, sir. But the process is more a kind of hidden one. Miss, is there any way to know the inner process of neural network, sir?
Inner process of neural network, not as a standardized form, but we can write our own code. Okay, so we can write our own code. So that again, kind of rewriting your algorithms. Technically, it is possible, but it's going to take some time. Technically, it is possible, but it's not a very straightforward, like code block that where we can go and write. So these are all processed in memory, correct? So if it's, even though it's a hidden network, correct? It's actually happens in a memory, correct? So we just have to get to that level to code.
Okay, thank you, sir.
Jyoti sir.
All right.
Jyoti sir, one question. Sir, can you differentiate between data warehousing and data lakes?
Sure, ma'am.
Yeah, please.
Yes, ma'am. Data warehouse, it's basically a traditional approach of bringing all the data in a very structured form. So that means you have a requirement. Let's say you have to create a report which lists in all the people who's living in the city of Hyderabad, below certain earning limit. So I wanted to create a report which tells me how many people are making 10,000 rupees a month. How many people are making less than 10,000 a month? So that means what? So I have to go out and bring all the people population, the number of people living, their demographic information and their earnings into a place. If you look at in a data warehouse, these are all brought in a very structured way. That means what I need their first name, last name, street address, age group, etc. And then where they work, occupation, salary. You see the field that I'm defining? So these fields are in data warehouse very clearly defined. You bring them and then store them. In a data lake, you don't have to worry about all these fields. You just bring a raw data. So you're going to bring if the demographic information has about 100 fields, you bring all the 100 fields. And second, you are not just bringing only for a specific purpose. You are bringing for the enterprise level view. For anything, everything, deal with this one. So data lake is a centralized architectural component where it stores all business informations in a raw format. Data warehouse brings data with a specific business problem in a very structured, methodical way. Correct? So the traditional way of doing this one, what data warehouse? You have a problem, you bring the data for that problem and store them. In data lake, you don't have a defined set of field. You bring everything. That is why data scientists need. And this goes back to the what feature I can select. So in a data warehouse, you bring only the feature what you think you needed. In data lake, you don't care any feature. You bring everything. Then you run this model and see how it performs. Change the model. Okay, change the feature. Run it. So data warehouse, you go with a limited defined set of field. In data warehouse, you bring all the fields for data scientists to work. And the data scientists will change the feature, change the data as they need it, as they see how the model is performing. So I hope this helps you.
So can I maybe understand that data warehouse contains only structured data, whereas data lakes can contain structured, semi-structured and unstructured data?
In both the cases, you can store structured and unstructured data.
Okay,
so the example that I would say, the example I would say, in data warehouse, you have let's assume that we have a logistic regression model to run. So the model is supposed to predict the customer churn. So for that, I initially identified only 10 features. So what happened in the data warehouse? You have only the 10 features.
Okay.
In data lake, even if you identify 10 features, but it's still going to bring all the features, correct? Whatever you think you may need it. If there's 100 features, you bring them. So now what you do, you experiment. I use the first 10 field, then 5 more field, then 5 more field, then 5 more field. In data warehouse, every time you have to get the extra fields. You don't have all the fields that is required. So when I say structured, it's a very limited.
Sir. Hello, sir.
All right. Yes, sir. I'm going to start here.
Participants, still, if you have any clarifications or any doubts, tomorrow also Jyoti sir is available. So please give some rest for a speaker. Next session will be start 2:30. Jyoti sir, thank you. Thank you very much, sir. It's more informative from you.
Thanks a lot, sir. Thank you.
Many of the participants are mentioned very informative and very excellent session. Thank you very much, sir. Thank you.
Sure. So thank you very much. So Durga Prasad is going to perform 2 demonstrations in a live system. So he's going to walk you through, and this is one of the requests from Dr. Abhilash, a gender detection and also handwritten digit detection using machine learning. The same example or use case will be shown in deep learning as well, so that he can understand how it works in both deep learning as well as the machine learning. So he's going to demonstrate these two as a second session in the afternoon.
Sir, kindly share the code in the afternoon, sir, so that we can parallelly try it out. It will be more interactive. Okay, thanks.
No problem.
Okay.
We will do that. We will do that.
Okay, thank you.
All right. So I will ask Durga Prasad to send it to you. So we will do that. Thank you very much.
Thank you, sir.
You all take care. Thank you. Bye.
Thank you, sir. Bye. Yeah. All the participants who completed your feedback, please leave the session. Participants, after completion of your feedback filling, please leave the session.